The learning outcomes for today's video lesson is the electrolysis of ionic compounds, in which I am going to explain how ionic compounds are conducting electricity and in which state. And the second outcome should be the movement of the ions to electrods. That once the ionic compounds is splitting into ions, where they are moving, how they are moving, what's happening to them when they approach to their respective electrode. And oxidation reduction, a brief introduction, or you may say a definition, and then the electrolysis of the molten ionic compounds. And we are going to just include the molten, not the aqueous, just to avoid the overlapping of the concept. So let's start. Okay. So in electrolysis, as you can see from the slide, that the ionic compounds, here is the picture shows that in the ionic compounds, the ionic bond is present and these ions are fixed and attached to each other in the solid state. Here, as you can see, solid copper chloride. Copper chloride is an ionic compound. So in the solid form, the ions are bonded to each other by ionic bond. They are fixed to their positions and they are not free to move. That's why the ionic compounds do not conduct electricity in the solid state, because the ions are not free to move. But in case of the aqueous or the molten form, after being dissolved, what happens? The ions become free to move. So once the ions are free, they can move to their respective electrodes to gain or to lose electron and can oxidize or reduce. I'm coming back to the slide after explaining you the oxidation reduction. So as you can see, here we are showing electrolytic cell where my cursor is rolling, and these black rods are the electrodes. One is positive, the other is negative. The ions which are free to move here, once they are molten, the negative ions are attracted to the positive electrode and the positive ions are attracted to the negative electrode, as per the principle that the opposite charges attract each other. So the negative ions get attracted to the positive electrode and lose their electron there and get oxidized, as oxidation is the loss of electron. So these negative ions are rich in electrons. So once they reach the positive electrode, they are going to lose the electron and get discharged or become neutral. How we are going to show this in our equation form? The negative ions will lose electron, and if you are writing it to the left hand side of the arrow, then you will write it with the negative charge, like this minus, not the charge on the electron, but I'm talking about this minus sign. And if you are writing it to the right hand side of the arrow as a product, then you will write it with the plus sign, like the addition sign. So because that electron means you are showing the electron being formed as a product and the neutral atom, whatever the ion is getting discharged, getting neutral, that is the product and the production of electron. So here in this equation, we have shown it to the left hand side. That's why we are using the minus sign here, this negative sign. So this is the one half equation of the reaction of this electrolytic cell, where the negative ions are coming and getting discharged by losing the electron, becoming neutral, and fluorine gas is formed. Same is the case for the at the negative electrode, where the positive ions are coming and gaining the electron, because this negative electrode is rich in electron. So, and the gain of electron is reduction. So these positively charged metal ions are getting reduced. And how to show the half cell equation? By adding the electron. Now see, we are adding the electron. Here it's written that they will gain the electron. Gain. So we are using a positive sign here. So the positively charged metal ion will gain the electron and become neutral and discharge. And this is how the metal atoms are getting separated from the compound. So the application of electrolysis is electrolysis used to separate the metal from its compound. So those metals which are present high up in the reactivity series, they form very stable compounds. So they cannot be reduced by using carbon and hydrogen. So they are electrolyzed to separate their metal, these metal, from their compound. So this is how it's going to work. The last objective is to explain the electrolysis of the molten ionic compounds. I have included the examples of lead bromide and sodium chloride as per your syllabus requirement of GCSE. So in case of lead bromide, when we are using molten, there is no involvement or competition of other type of ions. So there are just two type of ions, like one positive and the other negative. So these negative ions will move to the positive electrode, which is anode, and will lose the electron here. These electrons are traveling through the wire in the battery and coming to cathode, and the positive ions which are attracted to this negative electrode, which is cathode, so they are gaining the electron. So bromide ions are getting oxidized and the lead ions are getting reduced. So here see the bromine gas is formed, and here the lead metal is separated from its compound lead bromide. How to show the half cell equations at anode and cathode? Bromide will come at anode, it will lose one electron. Now see, but that's what I was talking about. When you're writing electron as a product on the product side, then you're going to use the addition sign to express these two products. So bromide ion is losing electron and becoming bromine atom. This bromine atom is very reactive. It cannot exist in the atomic state, so it will combine with other bromine atom and form bromine molecule. So this diatomic bromine is now in the gaseous form discharged at the electron. See the bubbles of the gas, bromine gas, you can see here. So bromine liquid is formed, bromine gas is formed, and the bubbles are there to represent the production of the gas at the anode. Now the second electrode, where lead is getting reduced, reduction is the gain of electron, so lead will go to the negative electrode as it is positively charged. It will gain electron there. See, we have shown it with the positive sign, and now the lead metal is formed. So this is another half cell equation. On both the electrodes at anode, oxidation, and at cathode, reduction takes place. And this is how you're going to represent the half cell equation. And if the question is coming, that is coming like name the products formed at the positive and the negative electrode, or anode or cathode when the molten lead bromide is electrolyzed. So this is how the products are formed. If they're asking you the procedure, then all this will be included, like my explanation. Not the diagram, I guess, but the explanation you will write the same. And here the products form bromine gas and lead metal. So moving next to the next example is sodium chloride, which is in the molten form ionizes to give chloride and sodium ion. Again same is happening. Chloride ion is going to anode and losing electron, forming chlorine atom. This is combining with another chlorine atom to form chlorine gas. These bubbles are representing the production of chlorine gas, and sodium is going to the negative electrode and getting reduced there by gaining the electron. The sodium metal can be represented like this, and molten form or getting discharged there at the electrode, and chlorine is produced in the form of a gas, and these bubbles are representing the gas. So mostly the question is we are observing in the past papers about this topic is name the products which are formed during the electrolysis of molten, any ionic compound they can give. So there is no competition with the water molecules, so no hydrogen and hydroxide ions are formed. So only the ions of the ionic compounds are discharging at their respective electrodes. So this was all about. In the next lecture, I am going to explain you the electrolysis of the aqueous ionic compounds. So let's review the whole topic. That the learning outcomes, what we discussed in this lecture was the electrolysis of ionic compounds, why they are not good conductor in the solid form, why they are good conductor in the molten or aqueous form. When the ions are moving to their respective electrodes, what's happening to them, what is oxidation, what is reduction, how to show the half cell equations at the respective electrodes, and then at the end I explained you the electrolysis of the molten ionic compounds. So this was all in today's video. If in case you need the explanation of any other video, please let me know, and I'll get back to you soon. Thank you so much. Take care.